Great. This is Unit 2, Lesson 5 on angles and auxiliary lines. This is the lesson video. So what is the measure of angle ABC? That is a review question. However, look at this diagram. We have more than one pair of parallel lines. We have 3 lines that are parallel to each other. And the angle ABC doesn't lie with a ray on any of those parallel lines. So notice here that we have 2 transversals. We have one at AB, and we have another transversal BC. So we can't just use one transversal and its angle relationships. We have to use more than one angle and its angle relationships. So again, review question, we're just kind of taking a look at this picture and trying to find out angle ABC. So we have 2 sets of parallel lines with 2 different transversals. So I'm going to look at this 75 degrees, and notice I have alternate interior angles here, which because the lines are parallel are congruent, so we know this portion is 75 degrees. Well, if I look at the other transversal, BC, and the parallel lines, I also have alternate interior angles. And those are congruent when the lines are parallel, which is given by these arrows here. This means that these 3 lines are parallel to one another. So the measure of angle ABC equals 75 degrees plus 45 degrees. And that gives us a measure of 120 degrees. So we have 2 different transversals. We can use alternate interior angles and the fact that the lines are parallel to find the measure of ABC. How does this apply to the lesson we're going to do today? So let's take a look at this example here. Okay, so I have 2 angles in here, and notice I have this dashed line. This is my auxiliary line. Right. Already in the diagram for you. Right, this dashed line is my auxiliary line. So sometimes an auxiliary line is useful when solving for unknown angles. Okay, in this figure we can use the auxiliary line to find the measures of angle E and angle F. How? Well, we'll go over that in a second. And then add the 2 angle measures together to find the angle of W. So angle E plus angle F will give us angle W, right? Those 2 together, angle addition postulate. If I add the 2 parts of the angle together, I get the whole angle. So how does this line help? Well, we drew this line through a point parallel to the given lines. So again, we have created another parallel line. And so we can use those special angle properties to figure out what the measure of angle E is and what the measure of angle F is. So we have 2 transversals. Here's one of them. And here's the other one. And they interact with that auxiliary line separately to create those special angle measurements. So what angle, how does E correlate on that green transversal? Well, those are alternate interior angles again. You won't always have to use alternate interior angles. Those are just the examples that happen to be at the beginning of this lesson. Interior angles. Okay. So angle E equals 41 degrees. Similarly, for the blue transversal, we have 35 degrees, alternate interior with angle F. We'll put 3 on there, 1, 2, 3. So angle F equals 35 degrees. And according to what we said before, if we add the 2 parts of the angle, we get the entire angle. So what is the measure of angle W? That would be 76 degrees. Again, the sum of E and F together. So we did one method. where we use the alternate interior angles using the auxiliary line to find E and F separately. So the measure of angle W is 76. Clearly, in the other diagram, that's going to be true. Method 2, I just want to show you that the auxiliary line doesn't always have to be using Euclid's postulate. So I just want to show you another way that you could do this. Again, this might not be used as frequently as drawing it parallel. Drawing parallel, definitely easier. However, we could extend this transversal into the given line that we have here. Right, this line is given in the diagram. It's not liking me right now. Hold on one second. Let's just, there we go. Okay, so how does that help me? Well, I still have these alternate interior angles here. So this is 41 degrees. But now if you look, I have a triangle, one of whose side creates an exterior angle W. So I could use alternate exterior angle theorem. Ooh, don't like that. Hold on. I could use alternate exterior angle theorem, and angle W equals 41 degrees plus 35 degrees, which again is 76 degrees. So I'm just showing you method 2 to show you that an auxiliary line does not have to always use Euclid's parallel postulate and be parallel to the given line. But for most of these examples, using the parallel line, using Euclid's postulate as the auxiliary line will be the easiest.